Hi there, I want to show you the new TULIP PCB. This is the pre-production version and I want to tell you some things about it. It's a 4-layer PCB with some components on the top, and on the bottom the inner layers are ground and power. So it should be good for signal integrity. So some of the parts here, this is the USB-C connector, the slot for the micro SD card. So this slides in here, as you can see. Here is the serial number, can be written onto it, and this is where the infrared LED is soldered. Here are connections for the backup battery for the artist. This is the 32 kHz crystal for the real-time clock. This is the 3-volt regulator with capacitors. This is a switcher for the power from the calculator or USB, and here is a level shifter for the FI input, so that is something extra. I had a nice logo designed by an AI tool, so that makes it a bit nicer. There are a number of test points. This is for the 5-volt from USB. This is for the 1-volt for the internal regulator. This is a test point for the system power, so I can check easily if the switching is correct between USB and the calculator power. There is a 0 ohm resistor here to enable or disable the power from the calculator, and another 0 ohm resistor which is not populated, and this is meant for the PWO output. I think the use is quite exclusive, so I didn't populate it, but you will get the 0 ohm resistor. There are a number of connector fields. This is, by the way, a 2 mm connector header, so it's a bit smaller, otherwise it simply wouldn't fit. Here is the ground, and here are the debug connections for the processor, and this is the run signal, and the run signal can be used to reset the processor. And on the bottom row are a number of signals. For general use there is the I2C, UART. This is ground, this is the USB boot, so you can force the processor in boot cell mode by simply connecting these two while connecting USB, and some other GPIOs that are either spare or used by the firmware. On this side is are the pads for the connector, but actually in most cases this will not be used because the connector will be mounted on the bottom side where the same pads are, but there is some work going on for a new connector, and then these will be used and these will be used. So if I take a connector, so normally you would expect it would go on top, but in this case it will go on the bottom for a real connection. The reason is that there are components on the bottom side, and in the housing we need some space for that. So the PCB has to be lifted a little bit by mounting the connector on this side. Now looking at the components on the bottom, here of course is the pads for the connector. This is a row of pull-ups and pull-downs for the application. These are the level shifters, shifting up and down from the 6-volt on the HP side to the 3-volt on the processor side, and the other way around, driving the signals. Here is the FRAM for persistent storage. This is the 12 MHz crystal for the processor, and here you see the real workhorse, which is the RP2350 processor. It has its own internal 1.1 volt regulator, and for that a very custom inductor is used, which is this one. Other parts are the flash memory. This is 16 megabytes of flash memory directly connected to the processor, and here is the real-time clock. Real-time clock is used for time module emulation. The firmware is not prepared for that, but it's there anyhow. This is a very brief overview of the TULIP module version. I'm starting verification. I know that the LED is blinking. By the way, there is a LED here. In case you wonder, this is how we get the PCBs. They're on a panel. This is a pre-production version. I've already written the serial numbers on it, so I don't get confused which are programmed and which are not. This is much cheaper and easier to produce if they're on a panel and not separate. The final production will probably be a bit larger to save on costs. And another thing is that for the battery backup, there is also a very small PCB and a battery clip. This will be hand soldered for a small battery to serve as the battery backup for the real-time clock.